In this video, we are going to talk about the geometric progression. To understand what is meant by geometric progression, we will consider a sequence 2, 4, 8, 16, so on and so forth. Here, we can obtain each term of this sequence except the first term by multiplying its previous term by a fixed number. For example, we can obtain 4 by multiplying its previous number 2 by 2. We can obtain 8 by multiplying its previous number 4 by a fixed number 2. We can obtain 16 by multiplying its previous number 8 by a fixed number 2. In other words, the ratio of second term 4 to the first term 2 is same as ratio of the third term 8 to its previous term 4 is same as the ratio of the fourth term 16 to its previous term 8 is same, that is 2. Now let's consider another sequence, which is 1 upon 9 minus 1 upon 27, 1 upon 81 minus 1 upon 243, so on and so forth. Here we can obtain the second term minus 1 upon 27 by multiplying its previous term 1 upon 9 by a fixed number minus 1 upon 3. Similarly, we can obtain 1 upon 81 by multiplying its previous term, which is minus 1 upon 27, by a fixed number minus 1 upon 3, and we can obtain the fourth term minus 1 upon 243 by multiplying its previous term 1 upon 81 by a fixed number minus 1 upon 3, so on and so forth. So here we observe that the ratio between the second term minus 1 upon 27 to its previous term, that is first term 1 upon 9, is same as ratio of the third term 1 upon 81 to its previous term minus 1 upon 27 is same as ratio of the fourth term minus 1 upon 243 upon its previous term 1 upon 81 is same, and it is minus 1 upon 3. Let us consider one more sequence 0.01, 0.0001, 0.50 and 1, so on and so forth. In this sequence also, we can obtain the second term 0.0001 by multiplying its previous term, that is the first term 0.01, by a fixed number 0.01, and we can obtain the third term 0.50 and 1 by multiplying its previous term, which is 0.0001, by a fixed number 0.01, and so on and so forth. In other words, we can say that the ratio of the second term 0.0001 and its previous term, that is the first term 0.01, is same as the ratio of the third term, which is 0.50 and 1, and its previous term, which is the second term 0.0001, is same, which is 0.01. Here the fixed ratios 2 minus 1 upon 3 and 0.01, that is 2 minus 1 upon 3 and 0.01, are called common ratios, and they are denoted by small r. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. This type of sequences are known as geometric sequences or geometric progression (GP). So therefore, in a geometric progression, we can find k plus 1th term, that is ak plus 1, by multiplying its previous term ak by a fixed number known as common ratio r. Hence, we get ak plus 1 upon this ak equals the common ratio R. Now, by using the first term A and the common ratio R, we can write a geometric progression as AR square, AR cube, so on and so forth, where this A is the first term and this R is the common ratio. This type of sequences are known as geometric sequences or geometric progression GP. So therefore, in a geometric progression, we can find k plus 1th term, that is ak plus 1, by multiplying its previous term ak by a fixed number known as common ratio R. Hence, we get ak plus 1 upon this ak equals the common ratio R. Now, by using the first term A and the common ratio R, we can write a geometric progression as AR square, AR cube, so on and so forth, where this A is the first term and this R is the common ratio. In the geometric sequences or geometric progressions that we have studied, the first term A was 2, 1 upon 9 and 0.01 respectively, and the common ratio R was 2 minus 1 upon 3 and 0.01 respectively. Now we will see how to write a general term of geometric progression or a GP. We have seen we can write a general GP as AR square, AR cube, so on and so forth. Here A is the first term A1 and R is the common ratio. Now we write the terms in this GP as A1 equals A, which we write in terms of R, AR to the power this 1 minus 1, that will be A R power 0, that is A. We write A2 equals AR, that is A R power this 2 minus 1, that will be A R power 1, or simply AR. Then we write A3 equals A R square, that will be A R power this 3 minus 1 equals A R square. We write A4, the fourth term, equals A R cube, that will be A R power this 4 minus 1, that equals A R cube, so on and so forth. In all these terms of the GP, we see a specific pattern, which is for the first term A1, the power of R is subtracted by 1 from this 1. In the second term A2, the power of R is subtracted by 1 from this 2. In the third term A3, the power of R is subtracted by 1 from this 3, which we write here. In the fourth term, the power of R is subtracted by 1 from this 4, which we write here. Now this pattern continues, and we can write the general term of this GP or the nth term of a GP as AN, which will be the first term A, then R is raised to this power n, which further is subtracted by 1. So this will be the nth term of a GP. Now we will see a few examples. The first example is find the 20th and nth terms of the GP 5 by 2, 5 by 4, 5 by 8, so on and so forth. In this GP, the first term A is 5 by 2 and the common ratio R is the second term 5 by 4 upon the first term 5 by 2. That will be 5 by 4 multiplied by 2 by 5. 5 gets cancelled. 2 ones are 2 twos are. So R is 1 by 2. We have the formula for the nth term an as a r power n minus 1. That will be a, which is 5 by 2, multiplied by r, which is half power n minus 1. That will be 5 by 2 multiplied by 1 upon 2 power n minus 1. That will be 5 upon 2 power 1 plus n minus 1. That will be 5 upon 2 power n, and this will be the nth term of this GP, 5 upon 2 power n. Now for the 20th term, we write A20 equals a r power 20 minus 1. That will be 5 by 2 into 1 half, which is r power 19. That will be 5 upon 2 multiplied by 1 upon 2 power 19, which finally gives the 20th term to be 5 upon 2 power 20. So our answers will be 20th term 5 upon 2 power 20 and nth term 5 upon 2 power n. In the next problem, we have to find the 12th term of a GP whose 8th term is 192 and the common ratio is 2. We have to find the 12th term A12 of a GP whose 8th term A8 is 192 and the common ratio R is 2. The 8th term A8 will be a r power 8 minus 1, that is a r power 7, and this 8th term is given to be 192. Now putting r equals this 2, we write a 2 power 7 equals 192. That gives a equals 192 upon 2 power 7. We divide this 192 by 3, that gives 3 6 are 18, 3 4s are 12. We write this 2 power 7 as 2 power 6 multiplied by 2. Now this 64 is nothing but 2 power 6. Therefore, this 2 power 6 cancels with this 2 power 6, giving us a equals 3 upon 2. Now this 12th term A12 will be a, which is 3 upon 2, r, which is 2 power 12 minus 1, 11. So that will be this 2 cancels with 1 2 from this and it becomes 2 power 10. So we get 3 multiplied by 2 power 10 will be 2 power 6 multiplied by 2 power 4. That will be 3 multiplied by 2 power 6 is 64 and 2 power 4 is 16. So that gives 64 multiplied by 48, which works out to be 3072. So 12th term of this GP will be 3072. Next problem is the 5th, 8th and 11th terms of a GP are P, Q and S respectively. We have to show that Q square equals P into S. Here 5th term A5 will be AR power 4. 8th term A8 will be AR power 7 and the 11th term A11 will be AR power 10. Now these terms in GP have been called as PQS respectively. So therefore A5, which is P, is AR power 4, A8, which is Q, is AR power 7, and A11, which is S, is AR power 10. Now we will divide this second equation by this first equation. So that will be Q upon P equals AR power 7 upon AR power 4. So this A gets cancelled and we get Q upon P equals R power 7 minus 4, that is Q. We call this equation number 4. Next, we will divide this equation 3 by this equation 2. So that will be S upon Q equals AR power 10 upon this AR power 7. This A gets cancelled and we get S upon Q equals r power 10 minus 7, that is r cube. We call this equation 5. Now the right hand side of equation 4 and that of equation 5 is same. Therefore we will write this q upon p equals this s upon q. By cross multiplication we will get q into q square, that equals p into s, ps. Hence this statement is proved here. Q square equals ps. In the next problem we have to find which of the sequence 2, 2 root 2, 4, so on and so forth is 128. In this sequence we have first term a equals 2 and common ratio r equals the second term 2 root 2 upon the first term 2. Here this 2 gets cancelled and we get common difference r equals root 2. Now since we have to find out which term of the sequence is 128, we will assume this 128 to be the nth term an, and we have for a GP an equals ar power n minus 1. So we write an equals 128, which is given a is 2 multiplied by r is root 2 power n minus 1. This we write as this root 2 power n minus 1 equals this 128 upon 2. So that gives 2 ones are 2 6 are 12, 2 4s are 8, that is 64. This we write as 2 power 6. Next we write this 2 in terms of this root 2 as root 2 square, and we will raise this to this power 6. So that will give root 2 power 6 2s are 12. The purpose of doing this is to make the basis of these two exponential numbers same, that is root 2. Now since the bases are same, we can equate their powers n minus 1 and 12. So we write n minus 1 equals 12, that gives n equals 13. So we conclude that the 13th term of this sequence will be 128. Next problem is the fourth term of a GP is square of its second term and the first term is minus 3. We have to determine its seventh term. Fourth term of GP will be a4, which we write as a r cube. The second term of GP will be a2, which we write as ar. Now it is given that fourth term of GP is square of its second term, which means a4 equals a2 square. That means this ar cube equals this ar whole square, that will be a square r square. Now we divide this ar cube by this a square r square and write ar cube upon a square r square, that gives 1. Now we will cancel this a with 1a of this a square. We cancel this r square from r square of this r cube, so that we are left with this r upon this a equals 1. That means r equals a. But the first term a is given to be minus 3, which means we have both r and a equals minus 3. Now with the help of the values of a and r, we can determine the seventh term. So we write a7 equals a r power 6. Substituting the values for a, it will be minus 3. For r, it will be minus 3 power 6. So that will be minus 3 multiplied by minus 3 power 4 into minus 3 square. So that will be minus 3 multiplied by 81 multiplied by 9. So a7 will be minus 2187, and this will be the seventh term. In the next problem, we have to find for what value of x the numbers minus 2 by 7, x minus 7 by 2 are in GP. If minus 2 by 7 x minus 7 by 2 are in GP, then we must have common ratio equals the second term upon the first term, that is x upon minus 2 upon 7, equals the third term upon the second term, that is minus 7 upon 2 upon x. Now by cross multiplication we get this as x into x square equals minus 7 upon 2 multiplied by this minus 2 upon 7. This 2 cancels with this 2 and this 7 by this 7, and that gives x square equals 1, or x will be plus minus 1. So when x is plus 1 or minus 1, these three numbers will be in GP. We will see how to find sum of n terms of a GP. For a GP, AR square, AR cube, so on and so forth, the nth term AR power n minus 1. Sum of first n terms of this GP Sn will be A plus AR square plus AR cube plus so on and so forth plus AR power n minus 1. We will name this equation 1. Now if common ratio R is 1, then Sn will become A plus A plus A plus A so on and so forth plus A n times, and it will be NA. Next we will consider if R not equal to 1, then we will multiply this equation 1 by R, so that we get R into Sn equals AR plus AR square plus AR cube plus AR power 4 plus so on and so forth plus multiplying AR power n minus 1 by R, we get AR power n. We will name this equation 2. Now we will subtract equation 2 from equation 1. So it will be Sn minus Rsn will be 1 minus R times Sn equals this A minus this AR minus this AR square minus this AR cube, so on and so forth, and finally we subtract this AR power n from AR power n minus 1 and write A minus AR power n. Taking A as common factor, we write this as A into 1 minus R power n. That finally gives us this Sn equals this A into 1 minus R power n upon this 1 minus R. Same sum, by reversing the signs, we can write Sn equals A into R power n minus 1 instead of 1 minus R power n upon R minus 1 instead of 1 minus R. So these are two alternate formulas for finding the sum of first n terms of a GP. Sn equals A times 1 minus R power n upon 1 minus R, or Sn equals A times R power n minus 1 upon R minus 1. In the next problem, we have to find the sum of first n terms and the sum of first 5 terms of the geometric series 1 plus 2 by 3 plus 4 by 9 plus so on and so forth. In this geometric series, we have A equals this one and common ratio R equals 2 by 3. So we write sum of first n terms of this GP Sn equals first formula A times 1 minus R power n upon 1 minus R. Now by using the values 1 multiplied by 1 minus 2 by 3 power n upon 1 minus 2 by 3. So that will be 1 minus 2 by 3 power n upon 3 minus 2, that is 1 upon 3. So sum of n terms of this GP will be 3 times 1 minus 2 by 3 power n. Now to find the sum of first 5 terms of this GP, we use this formula and write S5 equals 3 multiplied by 1 minus 2 by 3 power 5. This will be 3 times 1 minus 2 power 5 will be 32 and 3 power 5 will be 243. That will be 3 times 243 minus 32 upon 243. Now 3 ones are 3 eights are 3 ones are, and that gives us sum of first 5 terms S5 equals 211 upon 81. In the next problem, we have to find the sum of n terms in the geometric progression root 7, root 21, 3 root 7, so on and so forth. In this GP, we have the first term a equals root 7 and common ratio r equals this second term root 21 upon the first term root 7. This root 21 will be root 7 multiplied by root 3 upon root 7. Now this root 7 cancels with this root 7 and we get common ratio r equals root 3. Now with the help of the values of a and that of r, we will write the sum of n terms of this GP. We write the formula Sn equals a into 1 minus r power n upon 1 minus r. We will substitute the values root 7 multiplied by 1 minus root 3 power n upon 1 minus root 3. This will be root 7 multiplied by 1 minus root 3 power n upon 1 minus root 3. In order to rationalize this denominator, we will multiply both numerator and denominator by its conjugate, which will be 1 plus root 3 upon 1 plus root 3. So that will be root 7 multiplied by this 1 plus root 3 multiplied by this 1 minus root 3 power n upon 1 minus root 3 multiplied by 1 plus root 3 will be 1 square minus root 3 square, that will be 3. So this we write as 1 minus 3 will be minus 2. So we write this minus root 7 multiplied by 1 plus root 3 multiplied by 1 minus root 3 power n upon 2. For removing this minus sign, we will write the terms in this square bracket in the reverse order, so that the nth term of this GP Sn will be root 7 multiplied by 1 plus root 3. We have to write this bracket in the reverse order, so that will be first root 3 power n minus 1 upon this 2. So finally this will be the sum of first n terms of GP. In the next problem, the sum of first 3 terms of a GP is 39 upon 10 and their product is 1. We have to find the common ratio and the terms. In this type of problems, it helps if we write the first 3 terms of GP as a upon r, a and AR, where A is the first term and R is the common ratio. Now according to the first condition, the sum of these 3 terms is 39 upon 10. So we write A upon R plus A plus AR equals 39 upon 10. We name this equation 1, and according to the second condition, their product is 1, which means a upon r multiplied by a multiplied by ar is 1. This r cancels with this r and we get a cube equals 1. Considering real root of a cube equals 1, we write a equals 1. So the first term of this GP is 1. Now using this value of a in equation 1, we get 1 upon r plus 1 plus 1 into r, that is r equals 39 upon 10. This can be further simplified as 1 upon r plus r equals 39 upon 10 minus this 1. So that will be 39 minus 10, that is 29 upon 10. This will be 1 plus r into r square upon r equals 29 upon 10. Now by cross multiplication, we get 10 into 1 plus r square, 10 plus 10r square equals 29r. This we write as 10r square minus 29r plus 10 equals 0. This is a quadratic equation in R. In order to solve this, we will multiply this 10 by this constant term 10. That gives us 100. Now we will find two factors of 100 such that their sum will be minus 29, and two such factors will be minus 25 and minus 4. So by splitting this middle term, we write 10r square minus 25r minus 4r plus 10 equals 0. Now grouping these terms, we take 5r common, so that it will be 5r multiplied by 2r minus 5. Taking minus 2 common from these two terms, we write minus 2 multiplied by 2r minus 5 equals 0. So that gives us this 2r minus 5 multiplied by this 5r minus 2 equals 0. We get two values of r. The first value from this bracket will be r equals 5 upon 2, and from this bracket the second value will be r equals 2 upon 5. Therefore, the value of the first term a is 1, and two values of the common ratio r are 5 by 2 and 2 by 5. Now with the help of these two values, we write the three terms, which are these three terms, and they will be 1 upon 5 upon 2, that will be 2 upon 5, then 1, then 1 into 5 upon 2, so that will be 5 upon 2. Or these terms will also be equal to 1 upon 2 upon 5, that will be 5 upon 2, then a is 1, and AR will be 1 multiplied by 2 upon 5, that is 2 upon 5. So these are the first three terms of the GP. In the next problem, the sum of three terms of a GP is 16, and the sum of the next three terms is 128. We have to determine the first term, the common ratio, and the sum to n terms of the GP. When it is given that the sum of first three terms of a GP is 16, we assume the GP to be AR square, AR cube, so on and so forth. Now since the sum of first three terms is 16, we write A plus AR square equals 16. We can take A common, and we write this as A times 1 plus R square equals 16. We call this equation 1. Next, it is given that the sum of the next three terms is 128, which means that the sum of fourth, fifth and sixth terms, that is AR cube plus AR power 4 plus AR power 5, is 128. Here we will take AR cube, a common term, and write AR cube times 1 plus R square equals 128. We name this 2. Now from this first equation, we will get the value of 1 plus R square as 16 upon A, and we will use this value of 1 plus R square in the second equation here. So equation 2 becomes AR cube into this 16 upon A equals 128. Now this A cancels with this A, and we get R cube equals 128 upon 16. This will be 16 ones are and 16 eights are. So R cube will be 8. That gives R equals cube root of 8, that is 2. Now we will use this value of R here and find the value of this A. So we write 1 plus 2 plus 2 square, that will be 4, equals 16 upon A. So that gives A equals 16 upon this 7. So we have the first term 16 upon 7 and the common ratio 2. Now we will find out the sum of n terms of this GP. By formula, we write Sn equals A times 1 minus r power n upon 1 minus r. So that will be 16 upon 7 into 1 minus 2 power n upon 1 minus 2, that will be minus 1. So that gives finally sum of first n terms of this GP equals minus 16 upon 7 into 1 minus 2 power n, or by removing this minus sign we can write Sn equals 16 upon 7, and we have to write these two terms in the reverse order, so it will be 2 power n minus 1. So this is our answer, sum of n terms of the GP. In the next problem, given a GP with A equals 729 and 7th term 64, we have to determine sum of first 7 terms of the GP, that is S7. Now since A is 729 and 7th term is 64, we write A7 equals 64. That will be A, that is 729, r power n minus 1, that will be 7 minus 1, 6, which is 64. So we write r power 6 equals 64 upon 729. Now 64 is 2 power 6 and 729 is 3 power 6. So that will be 2 by 3 power 6. Now that implies r equals 2 by 3. Now since A equals 729 and r equals 2 upon 3, we will write S7 as A, that is 729 into 1 minus r power n, that is 2 by 3 power 7 upon 1 minus r, 1 minus 2 upon 3. So that will be 729 multiplied by 1 minus 2 upon 3 power 7 upon, this will be 3 minus 2, that is 1 upon 3. This can be further simplified as S7 equals this 3 into 729 into 1 minus 2 power 7 upon 3 power 7, that will be 3 into 729 into 3 power 7 minus 2 power 7 upon 3 power 7. Now this is 3, 729 will be 3 power 6 into 3 power 7 minus 2 power 7 upon 3 power 7. Now this 3 power 7 cancels with this 3 power 7, and we get S7 equals 3 power 7 minus 2 power 7, which will be 2187 minus 128. Now this subtraction finally gives us S7 equals 2059. Next problem is find a GP for which sum of the first two terms is minus 4 and the fifth term is 4 times the third term. Fifth term is 4 times the third term. This we write as A5 equals 4 times A3. We write A5 as A into r power 5 minus 1, that is 4, equals 4 times, for A3 we write A r power 3 minus 1, that is r square. Now this A cancels from both sides, and r power 4 upon r square will be r square, and that is 4. So we get r equals plus minus 2. Now sum of first two terms is minus 4. This we write as S2 equals A into 1 minus r, which is 2 power 2 upon 1 minus 2. Now this S2 is given to be minus 4. Now this will be 8 multiplied by 1 minus 4 minus 3 upon 1 minus 2 minus 1, that is minus 4, and this is 3a equals minus 4 and a equals minus 4 by 3. So we get the first set of values of a and r as a equals minus 4 by 3 when r equals 2. Now when r equals this minus 2, we write this S2 as a times 1 minus 2 square, that will be 4, upon 1 minus minus 2, that will be 1 plus 2, 3. Now this is given to be minus 4. So it will be 1 minus 4, that is minus 3a equals minus 4 threes are 12. So that will be A equals 12 by 3, 4. So we get another set of values of A and R, that is A equals 4 and R equals -2. Now with these two values we write the GP as A minus 4 by 3 into AR, that is minus 4 by 3 into 2 comma AR square, that is minus 4 by 3 2 square comma AR cube, that is minus 4 by 3 2 cube, so and so forth. This will be minus 4 by 3 minus 8 by 3 minus 16 by 3 minus 32 by 3, so and so forth. Now by using this second set of values of A and R, we write the GP as A, that is 4 into AR, that is 4 into minus 2 comma AR square, that is 4 into minus 2 square comma AR cube, that is 4 into minus 2 cube, so and so forth, and that will be 4 comma minus 8 comma 16 comma minus 32, so and so forth. So in this way we get these two GPs. The first one is this one and the second one is this one. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.